Welcome to the section of the immune system and the mind. We're finding out that attention deficit hyperactivity disorder is much more than just a behavioral quirk. It's a deep-seated neurodevelopmental puzzle. While we've long known about the pathogenesis involving psychosocial risks and brain regions like the cortical and subcortical areas, science is now looking at something surprising: the inflammatory status of the brain. Turns out that there's a fascinating link between attention deficit hyperactivity disorder and allergic or autoimmune diseases. It's almost as if the brain security team is a little too sensitive, leading to a state of chronic neuroinflammation. In this busy neural city, the residents include neurons and glial cells, all working under the management of the hypothalamic pituitary adrenal axis. But the real first responders getting a look attention lately are mast cells. These aren't just allergies, they are powerful actors in the brain's parenchyma, the hypothalamic region, and even near the choroid plexus. When mast cells get activated, they undergo degranulation, releasing a cocktail of inflammatory factors from their electron-dense cytoplasmic granules. We're talking about a chemical surge of histamine, tryptase, kinase, and heparin, along with tumor necrosis factor alpha and various interleukins. This chemical spike doesn't just stay in one spot. It affects the blood-brain barrier, potentially letting in T cells and other antigen-presenting cells that usually stay on the outside. These mast cells, which originate from CD34 plus hematopoietic stem cells, act like tiny chemical factories. They churn out prostaglandins, leukotrienes, chemokines, and vascular endothelial growth factor. While this is great for fighting off a cold in the brain, it can lead to cognitive dysfunction and exacerbate conditions like depression, post-traumatic stress disorder, or oppositional defiant disorder. The nucleus accumbens, the amygdala, the caudate nucleus, the hippocampus, the putamen are areas that rely on the delicate balance of dopaminergic, noradrenergic, and serotonergic signals. When neuroinflammation hits, it disrupts these pathways. Even common treatments like methylphenidate are being studied for how they interact with this inflammatory environment, which involves everyone from microglials and astrocytes to parasites in the subthalamic nucleus. Understanding this link between mast cells and the prefrontal cortex means we can stop viewing behavior as a moral failing and start seeing it as a complex biological symphony that occasionally needs a little help finding its rhythm.